A confidence interval is the statistic concept that is used to estimate the range of values that population parameter, such as population mean or proportion, is likely to fall within, given a sample of data. The range of values is calculated based on the sample statistics and the level of confidence desired. For example, if we calculate the 95% confidence interval for the sample mean, we can say that we are 95% confident that the true population mean fall within the calculated interval. The level of confidence represents the degree of certainty that the interval contains the true population parameter. Typically, a 95% confidence level is used, which means that if we were to take multiple random samples from the same population and calculate a 95% confidence interval for each sample, we would expect that 95% of those intervals will contain the true population parameter. It's important to note that the confidence interval is not a guarantee that the true population parameter falls within the calculated range. Rather, it is an estimate of likely range of values based on the available data and the certain level of confidence. The width of the interval depends on the sample size and the variability of the data, with large samples and less variability resulting in a narrow interval and greater precision.
This slide is discussing what a confidence interval is and then gives an example of how it can be used. A confidence interval is a range of values that we calculate from a sample of data, and it is used to estimate the range of values within which the true population parameter is likely to lie. In other words, it gives us an idea of how accurate our estimate of the population parameter is likely to be based on the data we have. For example, let's say we have data on 25 students, and we want to estimate the proportion of girls in the population of all students. We find that there are 15 girls and 10 boys in our sample. To calculate a 95% confidence interval for the true proportion of girls in the population, the exact formula depends on the specific situation, but it would involve the sample size, the sample proportion of girls, and the z-value for a 95% confidence interval. Once we have calculated the confidence interval, we can say that we are 95% confident that the true proportion of girls in the population is within that range. So for example, if our confidence interval is 0.4 to 0.8, we can say that we are 95% confident that the true proportion of girls in the population is between 40% and 80%. This slide is discussing how to calculate an 80% confidence interval for the proportion of girls in a classroom. To start, we use a formula that is similar to the one used for calculating a 95% confidence interval. However, the z-value, which represents the number of standard deviations from the mean, for an 80% confidence interval is different, and we can find it using a standard normal distribution table or calculator. We are then given the sample proportion of girls in the classroom, which is 15 out of 23, or approximately 0.65, and we use this to calculate the standard error, which measures the variability in the sample proportion. With the z-value and the standard error, we can calculate the confidence interval for the true population proportion of girls in the classroom. The final result is that we can be 80% confident that the true population proportion of girls in the classroom is between 0.473 and 0.827.